Welcome, ladies and gentlemen. So what I'd like to do is show you how to find the center, these vertices, foci, and asymptotes of a hyperbola. So in the last video, we basically did the exact same thing, but the center was always at 0, 0. So now what we're going to do is basically do the exact same process, but identify the center first. So I didn't write it up there, actually. But if you remember from ellipses, and as well as from parabolas, the center is always going to be h comma k. So even though there's so many differences between parabolas, ellipses, and hyperbolas as far as like what they look like in their equations, the h and the k is still the same. Also, remember that from a hyperbola to an ellipse, the values of a, b, and c are still the same. A represents the distance from the center to your vertices, b represents the distance from your center to your co-vertices, and c represents the distance from your center to your foci. Now again, in these videos, just because the graph of the hyperbola is not the same as a ellipse, the co-vertices are important and they are still there, but since they're not on the graph, I'm not going to worry about finding them. But remember, that's just finding b, and it's going on the conjugate axis, which is opposite of the transverse axis. Okay, but let's just kind of go through the steps here, and what I'll do is I will graph a vertical one over there just to kind of show you how we can use the co-vertices as well to help you kind of visually understand what the asymptote looks like. All right, so the first thing we want to do though is identify our a and our b. So remember, for hyperbolas, it's always a squared minus b squared, and a is not always larger than b like it was for an ellipse. That's one of the bigger mistakes that students always get. They always say, oh, well, a has to be 16. No, the equation for a hyperbola is always a squared minus b squared, a squared minus b squared. And if a is under the x, that means it's a vertical transverse axis. I'm sorry, horizontal transverse axis. And if a is under the y, that means it's a vertical transverse axis. So in this case, a squared is equal to 9. That means a is equal to 3. B squared is equal to 16. That means b is equal to 4. To figure out c, I need to use the equation, which is not the same as an ellipse. This is c squared equals a squared plus c squared, where an ellipse was c squared equals a squared minus b squared. So I do c squared equals a squared plus b squared. So I have c squared equals 9 plus 16. So c squared equals 25, or c equals 5. Okay. So now, the next thing you want to do is, again, identify the center is the first part. So our center is going to be h comma k. Remember, it's always opposite of h, opposite of k. So that's going to give me negative 4 comma negative 3. Once I know the center, the next thing I want to do is plot the information. I'll do just a rough sketch here for the first one, and I'll probably maybe try to do a better sketch over here. So I do negative 4, negative 3, 1, 2, 3, 4, 1, 2, 3. Now, one thing I didn't do in the other video that's a lot of times is helpful is to identify the transverse axis and the conjugate axis. The transverse axis is the axis that the vertices and the foci lie on, where the conjugate axis is going to be the axis where the co-vertices lie on. Just like the major and the minor axis, the transverse and the conjugate axis are perpendicular and they intersect at the center. So since I have my a squared is under my x, I know that my transverse axis is going to be horizontal, and my conjugate axis is going to be vertical. And that's just important because a lot of times, you'll forget and you'll start doing things the other way. So you just want to make sure they go through, and remember they intersect at the center. So now remember, to find my vertices, I got to go a distance of a from the center. Well, again, they have to go on that transverse axis. So my vertices, since they're going left or right, is going to be negative 4 plus or minus 3 comma negative 3. Now, I'll simplify this in a second. But basically, we're taking from negative 4, we're going to go to the left 3 and to the right 3. So 1, 2, 3, and 1, 2, 3. So those are my two vertices. Now, you could easily simplify that as negative 4 plus 3, which is negative 1 comma negative 3, and negative 4 minus 3, which is negative 7 comma negative 3. The next thing we need to do is figure out our foci. Again, our foci are going left and right from our center. So that's going to be a distance of c, which is 5. So that's going to be -4 plus or minus 5, comma -3. When we simplify that to our two coordinate points, that gives us -4 plus 5 is going to be 1, comma -3. And -4 minus 5 is -9, comma -3. So you could either plot those points, or from the center, you could just go left or right 5. And there's my two foci, so I know the graph's going to look something like that. Okay, I'm not really concerned about finding my co-vertices at this point in time. But I will show you in the next one do that. And then the last thing is we want to find the asymptotes. Now the only difference with this one is notice the asymptotes for a vertical and a horizontal are different. For the horizontal transverse axis, we have b over a. For a vertical transverse axis, we have a over b. And remember also we have an h and a k this time, so we need to plug it in. So in this case, I'm going to be y equals plus or minus b over a. B in this case is 4 over a, so that's going to be plus or minus 4/3 times x minus h, which in this case is -4. So that's going to be, so it's really x plus 4. And then plus y, which in this case is -3, so that's going to be a -3. You could obviously go ahead and simplify that, but just for, since we're not graphing, that equation is perfectly fine for me. All right, so in the next example, we're going to just do the exact same thing. You just go through, identify your a and b. It's always a squared minus b squared. So in this case, we have a squared equals 9, so therefore a equals 3. B squared equals 25, so therefore b equals 5. C squared equals a squared plus b squared. C squared equals 9 plus b squared, which is 25. C squared equals 34. C equals the square root of 34. Not 2. OK. So now notice that my a is under my y, so that means I'm going to have a vertical transverse axis. So what I'll do is I'll just write over here, center. In this case is opposite h, opposite k. Now remember, it's not h and k. Remember, h is always with the x, y is always with the k. So it's going to be +1, -2. So to graph that, again, I'm going to go ahead and create a graph. And I'm going to go over 1, down 2. Now again, remember, since my a is under my y, I'm going to have a vertical transverse axis and a horizontal conjugate axis. So now, from my center, to find my vertices and my foci, I'm going to be going up and down, whereas this one I was going left and right because the transverse axis was horizontal because a was under the x. Now a is under the y, I'm going to be going vertical. All right. So the next thing now I need to do is determine what the coordinate points are for my vertices. Well, you can do it a couple different ways, actually. You know from the center, you're going, to find your vertices, you're just going up and down 3. So you could easily just go count 1, 2, 3. Vertice 1, 2, 3. However, algebraically, we want to write that as our vertices are going to be now, we're going up or down, so I'm not going to be changing the x coordinate of the center. I'm going to be changing the y coordinate. So it's going to be 1, 2 plus or minus 3, which gives us our coordinate points of 1, -2 plus 3 is going to be 1, which you can verify right there is 1, 1. And 1, -5, which again you can verify over there. Next I'll find my co-vertices. Oops, not. Let's find my foci, because those are going to be up and down as well. So my foci are going to be a value of c. So that's going to look something like this. 1, -2 plus or minus the square root of 34. Now, I prefer just to leave it like this because that's going to give you some decimal approximations, which, you know, that's perfectly fine. However, you can break it apart into 1, -2 plus the square root of 34 and 1, -2 minus the square root of 34. Now, let's go and approximate what the square root of 34 is going to be about. We know that 5 squared is 25. 6 squared is 36. So 34 is between 25 and 36. So it's going to be 5 point something. So if I just wanted to graph this, from my center, I'd go up 5, 1, 2, 3, 4, 5, 6. So it's between 5 and 6. And from here, 1, 2, 3, 4, 5, 6. So it's in between 5 and 6. Okay, now I'm going to plot the covertices just to kind of show you how it's helpful when graphing, if you do have to graph. My covertices, notice, are on my conjugate axis. So that's going to be going left or right. So that's going to be 1 plus or minus b, which is 5. Okay, 1 plus or minus 5, comma, negative 2, which is going to leave me with 6, comma, negative 2, and negative 4, comma, negative 2. And if I was going to plot those points, you could also just go 5 units from the center, 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5, which I think is much easier than plotting the points, but you could just find the points and then plot them as well. What's nice about having the covertices is that if you draw perpendicular lines or vertical lines through the covertices and the vertices, what that can help you with is graphing the asymptotes. Because if those are your vertical lines through your vertices, or your vertices and your covertices, now what I can do is go through the center and the intersections of those points to show me what the vertices look like. And that's important because remember, when we're graphing a hyperbola, they approach these vertices. So you can see that this is a very, very wide hyperbola. Okay? So that's what the graph would look like. But in my video or for my problems, all I'm only going to be concerned about is what exactly are the asymptotes. So to do that, all we need to do is plug it into the equation. Since this is a vertical hyperbola, we're going to use y equals plus or minus a over b. So that's going to be y equals plus or minus a, which is 3, b is 5. So that's going to be 3/5 times x minus h, which is going to be x minus 1, plus k. K in this case you can see is negative 2, so it's going to be plus a negative 2, which is just minus 2. Okay, that's it for that one. Into the next one. Again, let's just kind of go through this really quickly. Let's find our a, b, and our c. So we can say a squared equals 4, a equals 2, b squared equals 16, b equals 4, c squared equals 4 plus 16, c squared equals 20, the square root of 20. So you take the square root of both sides to find c. C equals the square root of 20, which can be broken down into 4 times 5. Square root of 4 is 2 times the square root of 5. So now I know a, b, and c. I notice that my a is under my x, so I'm going to have a horizontal transverse axis. Next thing I want to do, I want to write down the center. Center in this case is going to be at negative 2, negative 1. So I go negative 2, down 1. Plot the center. I know that my transverse axis is horizontal. So therefore, I'm going to be going left and right. That means I'm going to be define the foci and my vertices. I'm going to be adding and subtracting a to the x-coordinate of the center. Notice how I'm adding and subtracting to the x-coordinate of the center. That's what happens when it's a horizontal. So to find my vertices, it's going to be negative 2 plus or minus a, which in this case is 2, comma negative 1. That gives me negative 2 plus 2 is 0, comma negative 1. And negative 2 minus 2, which is negative 4, comma negative 1. Now, when graphing my vertices, though, if I want to plot them on a graph, I just think it's much easier to go from C, go a to left, a to the right. So 1, 2, 3. 1, 2, 3. To find my foci, again, I'm just going to be going left and right from my x-coordinate. So I'm going to do negative 2 and plus or minus c, which in this case is 2 square root of 5. So that's going to be negative 2 plus or minus 2 square root of 5. You could easily approximate that. Square root of 20 is going to be 4 point something. If you wanted to graph it, but I'm not really concerned. 1, 2, 3, 4. Not really concerned here what the graph looks like. I just want to have a general idea. That answer's fine. I'm not going to rewrite it like I did over there. Last thing is just finding the asymptote, which is y equals plus or minus b over a. B in this case is 4. A is 2. 4 over 2 is 2. So that's going to be 2 times x minus h. So it's h is negative 2, but x minus a negative 2 is x plus 2. Plus k, which in this case is negative 1. So that's going to be minus 1. OK, last example. You can see that this graph is not set equal to 1. Right? So the first thing we want to do is divide by 9 on both sides. Just like the distributive property works for multiplication, the distributive property works for division. When we have an expression separated by addition or subtracted, divided by a number, both of those terms get divided. So therefore, in this case, now I have the new equation y minus 2 squared over 9 minus x minus 3 squared equals 1. So since this doesn't have a denominator, we can say that that denominator is going to equal to 1. And you can just go ahead and write that in. Now again, remember it's a squared minus b squared. So we have a squared is equal to 9. That means a equals 3. B squared is equal to 1. So that means b equals 1. C squared equals a squared plus b squared. So c squared equals 9 plus 1. C squared equals 10. C equals the square root of 10. So now to go ahead and determine the vertices, co-vertices. We can plot the information, but you know what? I'm going to try to do it without plotting the information. Since I know it's a vertical transverse axis, I know it's going to be going up and down. That means I'm going to be adding and subtracting the values of A to the y coordinate of the center. Notice how I did that. To the y coordinate, I'm adding my values of A and C. So my center, though, in this case, is going to be, remember, it's always opposite of h, opposite of k. Oh, did I make sure I just want to do that right? Negative 1, I did that one right. 1 comma negative 2. Good. So just make sure that that is your h and that's your k. So that's going to be a 3 comma 2, right? Because h is always with x, k is always with y. To find my vertices, so to find the vertices, I'm going to be going up and down a value of a. So from my center, I'm going to be going up and down a. That means I'm going to be changing the y coordinate. So that's going to be 3 comma 2 plus or minus 3, which is going to leave you with 3 comma 5 and 3 comma negative 1. To find my foci, I'm going to do the same thing, but I'm going to be adding plus or minus 5 to the y coordinate, or I'm sorry, whatever c is, which is the square root of 10. So that's going to be 3 comma 2 plus or minus the square root of 10. And I'll just leave it in that format. Lastly, to find my asymptote, I just plug in the information into my equation for an asymptote, which is y equals plus or minus a over b. So that's going to be a over b, 3 over 1, which is just 3, times x minus h, which is going to be x minus 3. And then plus my y, which in this case is 2. So there you go, ladies and gentlemen. That is how you determine the center, the vertices, the foci, as well as the asymptotes, for a hyperbola. Thanks.